Hello everyone, in today's session we're going to talk about multidimensional arrays. In today's session we will see what is a multidimensional array, how it works, how the elements are stored in the memory, how we can find the address of an element in the memory, and the time complexity of the operations. Stay tuned. Please keep in mind that in multidimensional arrays, again, we can keep a set of similar items in the memory continuously. Let's see how a two-dimensional array or matrix works. We have a set of elements and we have two dimensions, rows and columns, and when we want to store these elements in the memory, we have two options. First is the row major order, in which we store the elements row by row, and the second is the column major order, in which we store the elements column by column. In most of the programming languages, they use row major order, and in this session we also focus on the row major order, but you can extend whatever we are saying to the column major order by yourself. In row major order, we can look at the two-dimensional array as a set of one-dimensional arrays, and we slice them horizontally because we are looking at them in a row major order, and then we need to slice it horizontally. And the indices are zero based, and we need two indices, one for which shows which row, and the second one shows which column we need to access. In three-dimensional arrays, again, we can slice the elements horizontally because we are considering the row major order. And when we do that, we can see that the elements, each block of information is a two-dimensional array, and we can represent it like this. And we need one index in order to show which block, another index to show which row, and another index in order to show which column of that row is our target item. And when we want to store the elements in the memory, again, we follow the row major order. It means that we store all elements in the first row. The first row is a two-dimensional array. Again, we follow the row major order. Then we store A, B, G, H, and then we will keep doing this for all other blocks as well. In order to calculate the address of one element in the memory, we need to know how many items we have to pass, then multiply that by the number of bytes that each element needs to be stored in the memory, and then plus the start of the array. Then in any dimension, we need to know how many elements we have to pass. In one dimension, the index is telling us how many elements we have to pass, then the number of elements is k1. In two-dimensional arrays, k1, the first index, says how many rows we have to go down, and each row has this much element, plus then we will arrive at the beginning of one-dimensional array, and we already know how many index in one-dimensional array we have to pass, which is like this. Then we just plus k2, and that's it. In three-dimensional arrays, we have a set of two-dimensional arrays. The first index says how many blocks we have to pass, and each block has this much elements. Then k1 times these two will be the number of elements that we have to pass, and we will arrive at the beginning of a two-dimensional array. And for two-dimensional arrays, the formula is here. We just use that one also. It's similar to this one, and then we know how many elements we have to pass. We can rewrite this formula also like this, and in order to generalize this formula to any one-dimensional arrays, we are given n indices, and the formula is like this, that the first index times the total number of elements in the second dimension plus the second index, all of them times all of the elements in the third dimension, plus k3 times n4, and so on. We can generalize it like this. The access time in any dimension is O of 1 because we just need to calculate one formula. And search an element in a d-dimensional array is like this, and ni is the total number of elements in dimension I. I hope you enjoyed. If you have any questions or suggestions, feel free to contact me. In the next session, we will be talking about scanning the elements in the multidimensional arrays in an efficient way, and see you in the next session.